Hey guys, Mr. Milton here. Today we're going to talk about the triangle angle sum theorem. At the end of the video, you should be able to use the two theorems to find missing angle measures in the triangle, and you should be able to classify triangles by angles and sides. Alright, so here's the triangle angle sum theorem. You probably already know it, even if you didn't know it was called this. The measures of the angles in any triangle add up to 180 degrees. Every triangle adds up to 180. We'll use this forever. Okay, let's jump into some examples. All right, so we know that they gave us a triangle. We have this angle is 100 degrees, this angle is 48, and they want us to find the measure of angle 1. Well, we can say, well, these three angles together, 100 plus 48 plus, I'll just say x for the measure of angle 1, equals 180. So 148 plus x equals 180. And so x should equal 32. X is 32 degrees. That's a pretty simple example in the sense that, you probably would have seen this problem in a middle school class or even an elementary school class if I told you it was 180. What we'll see more examples of, shown here in the second example. Okay, we're given a bunch of triangles. 1, 2, 3, if you count the big triangle. We need to find x, y, and z. All right. Remember that when they give you these variables, I know they're in alphabetical order, but it does not mean that you have to approach it that way. So we're going to look at and see what we know. Strategy is to find a triangle with two angles solved for us. Okay, and there's two that I can see right now, but I see this one more clearly. So we have this triangle here. And I know that this triangle, it's a triangle, so it has to add up to 180. So I'm going to say, okay, 53 plus y equals 180. Subtract 53 from both sides. Gives me 127. So y is going to equal 127 degrees. Okay. All right. Now, that helps me out because when I look at x, there's a couple ways that we can do this. Actually, I'll skip that for right now. The other angle that I said that I saw, a triangle with two angles solved, was the big triangle. Okay, we have this big triangle. They told us that this angle is 57. They told us that this angle is 32. And they told us that sum of this angle is 21. The part that we don't know is z. So I want to say, well, these two added together was 89 plus 21, which is 110. Z plus 110 equals 180. And so Z is going to equal 70. Here. And then finally I can say, okay, 70 plus 57 plus x, I shouldn't have done it this way, will equal 180 as well. So x plus 127 will equal 180. And so x will equal 53. All right, and 53. You might have thought before, like, hey, I saw that when we found y, I said that x could be 53. And it could be, because these are a linear pair. They make up a straight line, so they should add up to 180 degrees as well. All right, so a couple things that we could have seen in that problem. This is probably more like the triangle angle sum problems that you have. The concept isn't too difficult. Triangles add up to 180 degrees. That's all their angles add up to 180. All right. Triangle exterior angle sum theorem says that the measure of each exterior angle of a triangle, equals the sum of the measure of its two remote interior angles. Okay, and I always like to think of remote, how my high school teacher told me. Think of the angles as a TV. You got 1, 2, 3 TVs. Okay, if I'm the exterior angle, number 4, I need a remote to turn on these two TVs or to change the channel. I don't need a remote to change channel for angle 3 because it's right next to me. Okay? So, what this tells us is that this angle is the sum of those two. Okay? Now here's what we know. They want us to prove that these two are the same. That measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. And we can do this. Because we're going to start and say, well, we know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. And we know that because they're triangle. If we wanted to say it, we could call it the triangle angle sum theorem. Triangle angle sum. Didn't probably give myself a lot of space to work, so deal with me. Make sure you're listening so you can hear my reasoning. Okay, step and reason. Okay. Now, from there, I can say, measure of angle 3, actually measure of angle 4, plus the measure of angle 3 equals 180. These two angles together add up to 180 because they're a linear pair. Linear pair. Or you could say they're supplementary, that's fine. But now, since I have two things that add up to 180, okay, angle 3 and angle 4. Or sorry, measure of angle 1, measure of angle 2, measure of angle 3, and measure of angle 4, and measure of angle 3. So what I see here is that actually, these two things must have the same value. So I can say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. And I'm just going to say that that's transitive. The transitive property? I hope so. If not, I'll have to come back and edit this. Okay? Transitive property. Or is that substitution? I'll say transitive. Okay. Alright, so there we go. Flip them to the back. Alright, some algebra with your geometry. Alright, we're going to find the measure of each of these angles of the triangle. Again, same concept. Actually, we're using the exterior angles. We know that this angle is 100. They told us this angle is 100 degrees. And so what we can say is, these two angles that they gave us are the remote interior angles. So since they're the remote interior angles, what we're going to say is, well, these two angles together, 9x minus 10 plus 6x plus 5, those two angles together add up to 100. It's remote exterior angle. And so now we can solve it. Adding these like terms together, 15x, like terms together, minus 5 equals 100. 15x will equal 105 by adding 5 to both sides. Oh no. Okay. So now I will divide 105 by 15. And that gives me x is 7. Notice that they did not ask us to find x. Okay, they wanted us to find the measure of each angle. So we're going to make sure that we plug this in and find that answer out just like they wanted to. So plug 7 in for x here, that's 42 plus 5. 7 in for x here, that's 63 minus 10 is 53. Okay, so they want us to find the measure of angle CAB. C to A to B, that's this angle, that's 47. They want us to find the measure of angles ACB. A to C to B, that's here, that's 53. And they want us to find the last measure, which is ABC. They didn't tell us this one, but we could have figured this one out from the beginning. Two ways. These two together should add up to 180. These three together should add up to 180. And so this will be 80 degrees. All right. Last, now, we are going to make sure that we are able Classify triangles by its sides and angles. So, by sides, here are the different types of classifications for a triangle. If all the sides are congruent, we call it equilateral. It's actually one word. I just separated it so you can see. Equal sides. If two sides or exactly two sides are congruent, we call it isosceles. Isosceles. And if no sides are congruent, we call it scalene. Okay. By angles, if all of the angles are congruent, we call it equiangular. Equiangular. If all the angles are acute, we can call it an acute triangle. If one right angle, other two angles are going to be acute, then we call it a right triangle. And if we have one obtuse angle, the other two angles are acute, or I say acute, but remember that means less than 90. Then we call that obtuse. All right. Some things that you might be able to associate with this: equilateral. Okay, we have a triangle with the dashes here. Isosceles. Triangle, we have dashes here. Scalene, we'd have a triangle. It'd all be different sides, no dashes to indicate the lines are the same. Equiangular, you might see something like this, where all the angles are arced. Acute, again, like they're not probably going to have anything to mark that it's acute. A right triangle can associate with a little square there. And obtuse, again, not very many markings, but you might associate it with something like that. Okay, excuse me. All right, so we're going to classify these triangles in this diagram here. So looking at it, they ask us for triangle MPR. Triangle MPR, that's this one here. All right, in order for us to really know what's happening, then we need to find the measures of these angles. Okay, we're going to do that by, okay, we have this is 90, this is 62. I know for that big triangle MNR, then I need to know that these three add up to 180. That's 135. And leaves me with 45 to fill. So this is 45 degrees. Okay, now that I know that this is 45, I can find out this angle because these two together is 118. 118 minus 180, or 180 minus 118. I think that's 62. Nope. Wow, did that wrong. 180. 118. 62. And that's when the calculator is not faster. Okay, 62. And that means that this is going to be 118. All right, so now as I classify these triangles, MPR, all of these angles are less than 90. And so that's an acute triangle. For MNP, we have one angle that's greater than 90. Okay, and so that will be an obtuse triangle. And then for MNR, okay, we have a right angle. So it's a right triangle. At this point, if they only give us angles, we're only classifying the triangles based off of their angles. Okay, so we weren't really given enough information to classify these based off of anything else, or off their sides. All right, so hopefully you can use the triangle angle theorem to fill in missing information from the triangles, and you now should be able to classify triangles based off of their sides and their angles. See ya.